Hello students. In this session we are going to learn about star to delta transformation. So what is star to delta? It is nothing but when the resistors are not connected either in series or in parallel, then they are said to be connected in star or delta. Okay. Suppose uh, there are two resistors like this. Okay. If a resistor is connected here in such a way that if you can see here, let this be R1, let this be R2 and let this be R3, then you can see here that due to resistor R3, R1 and R2 are not said to be in series, right? R1 and R2 are not said to be in series. So such type of disturbances which are not making the circuit either in series or in parallel are said to be in star or delta. Okay, so whatever this resistor connection is known as star connection, so it is represented with the letter Y. Okay, now delta connection is nothing but it is a triangle shaped connection. Okay, when three resistors are connected in such a way that one terminal or one end of one resistor is connected to another end of other resistor. Like here you can see this is R1, R2, R3. Okay, so resistor R R1's one end is connected to R2 and the other end is connected to R3. Similarly for R3, one end is connected to R1 and the other end is connected to R2. Like this connection is known as delta connection and it is represented with the symbol triangle. Okay. So how to convert the circuit when there is such type of connections? Okay, so to convert a star to delta, okay, so I am taking star to delta, star to delta, or Y to triangle. Okay, so to convert star to delta, you can see here star is nothing but it is a connection in shape of y, right? It is a connection in shape of y. So I am drawing a circuit with connection y. Okay, let this be points be A, B, C. Let this one be R1, this one be R2 and this one be R3. Okay, now I want to convert it into delta. I want to convert it into delta. So I'll take another color to represent it. So I want to convert this to delta. Okay. Okay. So this is a delta connection between point AB is, so let it be RAB. Okay. Resistor between RA and C, let it be RAC. Resistor between B and C, let it be RBC. So to convert a star into delta. So if you observe here a star point resistor, there are connection of two resistors. So to find RAB is equals to product of two resistors, that is R1 R2 plus R2 R3 plus R3 R1 divided by what is the resistor opposite to terminals A and B? It is a resistor that is connected to C, that is R3, right? So this is R3. So summation of product of two resistors divided by the opposite resistor gives you the resistance between A and B. Similarly, RBC same, product of two resistors divided by opposite resistor. What is the resistor which is opposite to point B and C? It is A. So that is R1. Similarly for RAC, it is R1 R2 plus R2 R3 plus R3 R1 divided by what is that resistor which is opposite to A and C? It is point B, that is R2. So this is how you are going to convert a star into a delta. Star into a delta. So now if you want to convert a delta into a star, delta into a star. So here I have taken delta resistor. Now I want to convert it into star. So draw the star connection diagram for this. Okay. Okay. Let this be points uh, 1, 1, 2, 3. Okay, 1, 2, and 3. Or you can also take A, B, C, because I already have taken that 1, 2, 3. A, B, C. Okay, A, B, C. So this resistor is RA. This resistor is RB because it is connected to point B. This resistor is RC because it is connected to point C. Now, to convert a delta into star, delta into star. So what I'm going to do, what I want, I want. Okay, RA is equals to this point A, what are the two resistors connected? That is R1 and R3. So multiply the two resistors divided by summation of all the resistors, divided by summation of all the resistors will give you the value of RA. Similarly, RB. What is the resistors connected to point B? R1 and R2. So R1, R2 divided by summation of all the resistors. Similarly, RC. RC, what is that? R2 and R3. So R2, R3 divided by R1 plus R2 plus R3. So first, to convert any star to delta, you need to first mention the points, mention the resistors. Okay, mention the resistors with the points what you have mentioned, either it has numbers or it has uh, this alphabets. Okay, so here I have converted star to delta. So star to delta, you need to take summation of two products divided by opposite resistor, or delta to star, it will be product of two resistors which are connected to that point divided by summation of all individual resistors. So kindly remember this formula because it is a question given in 2017 for 5 marks, where actually you need to elaborate the derivation, but in a simple manner to remember the formulas I have mentioned you like this. Okay, so if after derivation you need to get this formulas for calculating star to delta or delta to star. So with this I will be continuing the problem. Okay, so this is a circuit which is given in 2018 for 6 marks. What is asking? Obtain the equivalent resistance for the circuit shown in figure and use it to find the current I. So where is the current flowing? It is flowing from the source. Okay, he is asking us the equivalent resistance. So where to find out equivalent resistance? Here already points A and B are given. So we have to find the equivalent resistance between points A and B. Okay, so first what we have to do, we have to look the circuit from the back, because we have to simplify the circuit from the end of this term. Instead of source, we have to take it from the back end of the circuit. So how you are going to observe what they are connected? So if you see here, a parallel connection of 30 ohm is connected to a network which is neither in series nor in parallel, right? If you see here, if there is no 5 ohm resistor, then 12.5 and 15 are in series, and 10 and 20 are in series. This combination is in parallel with these combinations, right? But due to resistor 5 ohm, it is neither in series nor in parallel. So first we have to convert delta into star or star to delta. So let us solve this by using the terminals like this. So let this be point A because it is connected to A. So what is this point? This point is also A. Next here this point is B. So what is this point? This is also B. Okay. Okay, so A and B. So if you observe here, if you observe here, these are two common points, right? How this is connected? They are in delta. So now first convert delta into star. Convert delta into star. So what is the delta what we are taking? It is, this is point A. Okay. So let us mention the points C and D because B is already there. So C and D. So it is C, it is D. Okay. So this is 12.5 ohm. This is 10 ohm. This is 5 ohm. Right. Now convert this delta into star. This delta into star. Let me take another color. So this delta I need to convert it into star. Okay, this delta I am converting it into star. So what is this resistor? As it is A, so it will be RA, this will be RC, and this will be RD. Right. So how to convert star to delta to star? So delta to star, RA is equals to, what is the resistors connected to these 2 points? That is 12.5 into 10 divided by summation of all. 12.5 plus 10 plus 5. Right. So this value is 4.54 ohms. Okay. This is your RA value. Similarly, find out RB. RB is equals to, sorry, RC. Okay. This point C. So RC is equals to 12.5 into 5 divided by 12.5 plus 10 plus 5. So what is this value? Its value is 2.27 ohms. Next, RD. So 5 into 10 by 12.5 plus 10 plus 5. So what is this value? This value is 1.81 ohms. Okay. Now replace the points what you are taken from the delta into star. How we are going to replace? First draw the circuit as it is up to that points. Okay, this is point A what we have taken and this is point B. Okay, so here a resistor is connected, that is 30 ohms. Okay, next here there are two resistors which are connected like this, that is 15 ohm and 20 ohm. Okay, this is point C and this is point D. Now I am going to draw the star connection. Okay, this is what I am replacing, this circuit I am replacing here. So what is RA value? RA is 4.54 ohm. This is RC. What is RC value? It is 2.27 ohm. Next, this is RD. What is RD value? It is 1.81 ohm. Now, if you observe the circuit, you can see here that 15 and 2.7 are in series, right? 20 and 1.81 are in series. So that combination is in parallel and this circuit is in series with RA, and after calculating this total value it is in parallel with 30. Okay, and after that you can find out value of current by using the formula I equal to V by R equivalent. Right. So we are going to solve it. So again I am drawing the circuit. Okay. This is 30 ohms. This is 4.54 ohms. This is 1.81 ohm. And this is 20 ohm. This is 2.27 ohm. And this is 15 ohm. This is 120 ohms. Here we need to find out the value of I. This is point A and somewhere this point is B. Okay. So let us solve that. So the parallel combination will be now like this. Okay. So 30 ohm, 4.54 ohm. So I am directly adding here because these two are in series. So R1 plus R2. So it will be 17.27 ohm. Here also series. So R1 plus R2. So 20 plus 1.81. So it is 21.81 ohm. Okay. This is 120 ohms. This is the current we need to find out. So what is the parallel combination of this? So parallel combination will be uh, so let this is C, this is D, and this is B. Huh? Okay. So parallel combination of two resistors. Let this be R1, R2, R3, and R4. Okay. So parallel combination of R2 3 is R2 R3 divided by R1 sorry R2 plus R3. Right. 17.27 into 21.81 divided by 17.27 plus 21.8. So what is this value? This, okay. So this is that thing, and next R123 is equals to the value of this equivalent to uh, 17.27 into 21.81 divided by 17.27 plus 21.81 plus series combination. So this value is 14.17 ohm. Okay. Now this is in parallel with 4. So R13 4, which is equal to R123 into R4 divided by R123 plus R. So what is the value of R123? It is nothing but 14.17 into 30 divided by 14.17 plus 30. Okay, so this value is 9.62 ohms. Now I want to find out the value of current. Current I is equals to V by R equivalent. So this is nothing but your R equivalent. So it is 120 divided by 9.62, which is equal to 12.47 amperes. Okay, so hope you have understood this problem. First you need to verify whether the circuit is in series or parallel. Then you need to check if it is possible, then you need to solve it easily. If you find it difficult, with that is they are not connected in series or parallel, then you need to see that whether they are connected in star or delta. So if they are connected in star or delta, so you convert one form to another form and you replace the circuit from where you have taken that form, and you can see that there will be a series and parallel connection, and you can solve it in this simple manner. Okay, so try to learn such type of problems and practice more so that you can do it easily in your examinations, right? Thank you.